Hello everyone, welcome back. I am Vijay and today we are going to learn about the software needed to set up the ROS environment. So let us get started. That we have the understanding of everything is built in a package, and then a package can have multiple nodes. Multiple nodes can communicate to each other using topic, services, and actions. All these are called as interfaces, and we have parameters which can be used to configure node from outside without changing any code written in the nodes. And then we have batches for recording all the processes for further analytics. And the ROS2 provides all necessary libraries, tools, and frameworks to build and run robotic application. This includes core functionalities like communication tools, visualization tools, and support for real-time systems. We will be using Ubuntu 22.04. So this will provide a stable and compatible environment for running ROS2 with the added benefit of strong community support. You can install Ubuntu on a standalone machine or use a dual boot system or Ubuntu virtual machine or Docker container. Ubuntu virtual machine and Docker containers are recommended only for the non-GUI applications. So if we want to use GUI applications such as Gazebo and ROS, so it is not recommended to run ROS2 on a virtual machine and Docker images. So I highly recommend that we should use a dedicated Ubuntu machine or at the max dual boot system. And whenever we write a package, we need to compile that package, and we use Colcon to compile a package. Colcon is a powerful build tool specifically designed for ROS2. It handles dependencies, build multiple packages efficiently, and make it easier to manage complex robotic projects. As we know that ROS2 supports both Python and C++, we will need development environment for these languages, Python and C++. These tools will allow us to write nodes, build packages, and execute code across various robotic platforms. So we'll be using rather Python, even not C++, but wherever required, we'll be using C++, as we can write custom interfaces only in C++ package. So there we'll be using C++. Otherwise, in this particular course, we'll be only dealing with Python nodes and other things. For writing and editing code, we'll use VS Code. It is a flexible, lightweight code editor with great extensions for ROS2, even the other developing environment also. It's providing a syntax highlighting option, auto-completion, and debugging tools to make the development easier and faster. For those interested in simulation tool before testing on the real-world hardware, so we'll be installing Gazebo also, which is high-quality simulation environments for ROS2. This allows you to develop and test robotic algorithms in a virtual space. That is what we'll be doing in the next course. And for visualizing our robot state, sensor data, and environment in real time, we'll use RWiz. This tool allows us to display everything from 3D model to camera feed and sensor data. RWiz helps in understanding how robot perceives and interact with the world. Is the visualization tool, and Gazebo is the simulation tool. So as our robot system grows, it becomes essential to visualize and communicate between nodes, and RQT graph is a powerful tool that generates a live graphical representation of all the nodes, topics, and services in your ROS2 system, and that it makes it easy to debug and understand how information is flowing from one node to another node. It's all essential that we have to manage and collaborate on our code. So for that, the version control system GitHub we will be using. And this version control system allows you to track changes, work collaboratively, and maintain multiple versions of your project without any problem. It's an essential tool for any software development, especially when working in team or across multiple devices. But here I am suggesting that you can or cannot use it. But if you use, this is an optional tool. If you use, it is going to be a great help for your project. To help you get familiar with ROS2 concept early on, a very good package is available in the ROS2, and that is TurtleSim. So we'll use TurtleSim, a simple graphical simulator, 2D simulator to be precise. It is a fun, beginner-friendly tool that lets you control a virtual turtle using ROS2 nodes and topics. So finally, we will install ROS2 CLI tool, that is command line interface, to interact with system from terminal. These command line tools helps to monitor nodes, topics, services, and actions, making it easy to control and debug. And few more things that we might also use, rather we will be using in maybe in the next course. One thing is the URDF, that is Unified Robot Description Format, and Zacro, that is XML macro. They are the crucial components in ROS2 for defining and managing robot model. So URDF is an XML format used to describe a physical structure of robot, including its length, joints, sensors, and visual elements. So the model design in URDF and XML, it can be imported to RWAs and the Gazebo for further understanding. It provides a standardized way to define the robot's geometry, kinematics, and dynamics. And Jacro is an extension of URDF that allows the use of macros to simplify the creation of URDF files, because we'll be using URDF files for describing our robot. And instead of manually defining every part of robot, we can use Jacros to create a more manageable and modular description. If you find this tutorial helpful, do not forget to like this video and subscribe for more tutorials. Until next time, happy learning. Thank you.